All right, and hello. I thought I would make a brief update on what I'm thinking about with this hydraulic cylinder for the robot. I always like to add this. Again, a robot's walking. I don't know if this is going to be a YouTube. It probably won't. But I do like to remind everybody involved that it is a physical structure, and this is something we're going to put pressure in. And anytime you put pressure inside of something, it has a potential to hurt somebody. So any physically real object could hurt somebody. When you're managing a physically real object, my advice is manage it in a manner that is legally allowed and reasonable and safe. And if you can't manage it in this way, then my advice is do not create it as a physically real device. So let's go take a look at it. Now this is in SketchUp. It's not as pretty as KeyShot, but I can do it much quicker. This is the Halite. This is one of the companies that makes the seals. And this is a screenshot of one of their pages. And what they do is they will show what they want these grooves to be, what the size is, what the radius can be of these curves, and what the width can be. The width they call L1, and the height of it is the difference between big 0, big D1, minus big 0, little d1. That's how high they want it to be. And this shaft is going to be a 1/2 inch shaft. So you go down here, and the big diameter is 0.75 and the little diameter is 0.5. So this height then becomes 0.25 inches, and the width of this opening becomes 0.207 inches. And the length of this seal item is 0.207. And then they go over what they want the smoothness to be. These are static faces. These don't move. And the dynamic face is down here where the rod is. And this is the RA in micro inches that they want it to be at. So I'm going to make a much better video for you. Now in the hydraulic seal systems, this is the shaft, this is the seal, this they call a bearing or a spacer. This spacer keeps this rod from running into what they call the housing, the metal surround. And so the seal itself prevents it from leaking, but this material prevents the shaft from running into the housing. And this is also sold by Halite. And there's all sorts of specifications of how big it needs to be. And all of this has been drawn to scale. Now I have drawn this times 10. My program prefers times 10, so this is showing itself as being 5 inches, but it's actually 0.5 inches. And I'm using the Delrin tubing that is 1.5 inches, 1.25 inches in diameter, because it has 1/8 inch thick walls, and the inside dimension is 1 inch. So the inside diameter is 1 inch, and this is the piston rod, which is a 1/2 inch. And what I'm working on is making this so I can seal it up to get pressure in it. And I'm going to put the pistons in here, and the pistons will be connected to the outside world through the piston rod. And there's 2 features that need to be created. One feature is a device that clamps onto this Delrin, the polyacetyl or polyacetate. It's got a number of different names, but DuPont invented it, and they named it Delrin. and it's POM, polyoxymethylene, Delrin, DELRIN. And this is available for sale from McMaster Carr. I'll show you all those websites. And this is a 1024 socket head bolt with a nylon insert locking nut, and these bolts will be made of brass, and this nut will be made of stainless steel. I don't want to use stainless steel on stainless steel because it galls and it'll lock it up. These metals are all brass. I think the red brass. I put them in different colors so you can keep up with what's going on. And this is the cross section. Like, for example, this clamp is 1.1 inches long, and this thickness from here to here is 0.59 inches, and this bolt would be 1.28 inches long. So that's how it works. And what I did with this clamp is in SketchUp, okay, SketchUp has a feature where you can make a circle. It's called Follow Me. So I can make a circle that's, so I'm going to put 2.5. So that's a circle that's a 1/2 inch in diameter. And I'm going to take this group and copy it, paste it in place, and so make it so it's not a group by exploding it. And then I'm going to select this. That becomes the path, and I can choose the option of Follow Me. And when I do that, it converts this into this structure. And so that's all this is what I just did there. So that's how this works in SketchUp. And what I did with this structure is, I am hoping that this is not something hard for you guys to do. This is the red brass. And I'm going to defer to your opinion. If you would like to use something else, I don't mind. I just want the hydraulic fluid to be water. And then another thing that you can do in SketchUp is called subtraction of solids. So this is a solid, and this is a solid. So I can take this solid and subtract it from that solid, and you get this. So I'm going to undo that. And you get this structure that looks like that. And then I'm going to say, well, let's make this part right here and take your bandsaw. I went out on the internet and said, well, what is the thickness of a bandsaw? And they said 0.032 inches. Remember, this is times 10. So I put this thing in here like this. And again, and this is a solid. So I took this solid in SketchUp and subtracted it from that. And that's what you get, is this. So I'm going to undo that. So now you have these two pieces, and it's a little bit difficult to split them apart, but you get them apart, and then you take this piece here and you put it in your CNC machine, and you grind it down so this is flat and smooth, and the separation between them is 1/8 of an inch. And the way this is designed is, in the Delrin, there is a groove in it. There's that groove, and the curve of this groove matches the curve of this structure. And these little 1/32 inch teeth stick down into the Delrin. So the Delrin stops right here, and these teeth are pushing down into it, and that grabs a hold of it. And it is my hope that that will hold it strongly enough that it won't go anywhere. And when you cut this cutout on this, you can do this cutout on both sides, and then you can do the same cutout on the other sides, and then you can take one of these 1024 bolts and put it on here, and it bolts it together, and you squeeze these little ridges into the Delrin. And here's the question, will that work? I don't know if it'll work. I hope it'll work. I hope this will work. It's very important that it's not too expensive. That's another issue. All right, so now we've got a metal. We've taken the Delrin and given ourselves a metal piece to work with. And so now we're going to make the piston rod seal structure. And the piston rod seal stuff is a lot more complex because you have to do what they tell you to do or it won't work. So they want this bearing or spacer. This goes right there. And they have very specific distances. And I'll work that all out for you. And then the seal goes right there. And this is what is called a split gland or a split seal, because I spent my whole life working with tools and surgical instruments and working down inside of people, moving things around. And I have these big, thick hands and thick fingers that people have who work with their hands. And I don't think there's a chance in the universe that I can get my hands inside of this. One of the ways to do these is you bend this around and you get it in there, and I just don't think it's going to work. So, but there's another way, which is you make this little cap here and you take this seal and you push the seal into right there. So it's where it's supposed to be. And then you take this cap, and this cap, I made this curve. You can see that this curve of this is the cap. It's the same thing here where I put that circle there and said, follow me, and it turns it into a solid. So this curve is made where this cap comes forward like this and pushes that seal where it's supposed to be, like that. There it is, okay? And I'm going to defer to your opinion. I made this absolutely exact, and my bet is you're going to advise that this should be like 3/1000 or 2/1000 larger. I don't want to make something that's so precise that you one tiny little piece of dirt and it won't go together. So that's this structure, and inside of here, right there, is where that, I might be able to get that to show. Hang on a second here. This is where I'm going to have to do this with my hands, and I'm just hoping that I can. I'm going to have a positive attitude, but this has to go right there. So this is in there, and there's the seal. And they make this where they have cut it for you with this angle cut. I made that cut too, just to show that. This is something that you can buy. They give it to you. They don't give it to you. You have to buy it. All right, and I'm using a square cross-section O-ring, and I made the, this is a piece of the Delrin. There it is, with its cross-section in it. And so this thing is here. I haven't put in, there's these two number 1024 socket head brass screws with nylon insert stainless steel lock nuts on them, and they're squeezing this together. And then this has been put on there, and here's another one of these socket head brass bolts with a nylon insert stainless steel locking nut, and that bolt pulls this against that. And so I'm going to put probably eight of those is what I'm thinking. And of course, there's also going to be in addition, you have to have another bolt that pulls this two-piece cap on. So we got to move that guy a little bit. So we took this cap right here and pulled it up against that, and we pulled it up against that and it will have in it these brass socket head bolts with the nylon insert stainless steel locking nuts, and they pull this cap against this surface. And I haven't shown them, but they go here. There's maybe 6 of those there. So there's going to be 6 of those bolts there, and there's going to be another 6 bolts going around there, and that pulls the whole thing together, because I want to make this where I can put it together and take it apart, because I have a feeling that I'm going to spend my time trying to get this to work, and I need to be able to put it together and take it apart. And so I did a kind of a split view, and you can see the little grippers, and this is machined into it by your CNC machine. And so this is gripping this, and then this is going together, and then this is being held onto that by these bolts, and this cap is being held onto this by these bolts. And I did a cutaway, and here is, I don't have the bolts in there, but here is this cap, this 2-part gland or 2-part seal, where this is pushing this blue seal into its little spot. And this, I hope, by some piece of magic, I can maybe, they do make tools for working with O-rings, and I did a lot of work with instruments, so I'm hoping I can get that to go in there. And then this is the 1/2-inch shaft, and this is squeezed tight by those bolts, and this see how this shapes around so it'll hold this square cross-section O-ring, and this purple piece is being pushed up against this purple piece is being pushed up against this part of the square cross-section O-ring, and the Delrin tube is being pushed against the other side of it. So that should seal it. And then I did make very quickly, it's this same, it's a slightly different, but it's the same cap, and it's that same thing where you make this, you copy this, and then you explode it. Then you choose this and say, follow me, and it turns this into that. So this cap is the cap that goes on the other side, because we have to have this complex cap on this side so we can have a piston rod. But on the other side, it's just sealed up. And the final thing I wanted to show you is that I created this negative version of a 1/8 inch national pipe thread set of threads. And I took that set of threads and I put them in here. So this is a group, and this is a group, and I took this group and subtracted it from that group. And when you do that, you wind up with this. Okay, and this is a 1/8 inch national pipe thread threads, and the purpose of this is to get the hydraulic. They're going to be another one of these 1/8 inch national pipe thread fittings on this end, so that you can put fluid into that end of the hydraulic cylinder. And the way you put fluid into the other end of the hydraulic cylinder is with this you drill through here and then tap it. And then we're going to have some pistons in here. I haven't done anything with the pistons, but oh, and so remember, everything is times 10. So this structure will be 3.4 inches long, and it will be this big one is 4.2 inches in diameter, and the thickness of these support surfaces is 0.4 inches, so that ought to be strong enough. And this one on this side is 0.3 inches. So I'm hoping that will work. And I'm going to give you all these dimensions, but I thought you'd get a kick out of just looking at that. Now, as you know, I make everything different colors, and I also have the ability to lower the opacity so you can see through it. And that's what I've done to show it. The real thing, this will all just be probably that gray metal color. Oh, yeah, no, it'll be brass. It'll be brass color. I guess it'll be this. And again, the reason I'm picking brass is because I don't want to use stainless steel if I don't have to. And I do want to use a material where water will not, it doesn't care if it gets water on it. Anyway, I'll prepare a more formal presentation, but I thought you'd get a kick out of that. Hoping you're having a good day so far anyway. Oh, I did want to show you something that is really nothing more than just for fun, but you know, I haven't used it yet. Don't tell people about it. But I made little mannequins. I put them in my YouTubes to show scale. So they're the size of a human being. And they're walking along pushing this cart. And I'm going to put into my YouTube like I'm talking to them, saying, so what are you doing there, guys? And they'll say, well, we have this cart with little boxes, and each of these boxes are full of these gold medallions. These gold medallions are a Christmas present that I created in SketchUp. I mean, it's in Keyshot. I talk about them on my website. And it's like, well, what are you doing exactly? They say, well, each one of these little fence posts has been marked with the name of a corporation like Intel and Qualcomm and Parker Hannifin and Tesla and DARPA. And we're supposed to push it along and go to each of these little stops and tell them, if you want to look at using hydraulic cylinders for human mimicking robots, that's really the secret answer that will give you a robot that you'll be able to sell as many of them as you want to, and to help you and encourage you and be smart and agree with you that you've decided to do that. If you want, we'll give you one of these little boxes full of these gold coins if you want to do that. And I'll say, and so you guys have been now pushing this along this walkway here, and you've been to some places. Yes, we have. And how's it going? Well, I mean, we go and we offer it to them. And so now, if you don't give them all away, what are you supposed to do? Well, have been told we take them down to there's a river at the end of this walkway, and we're going to take all the coins we didn't give away and just throw them in the river. And I'm like, or they will say, and so you've been to all these places, and I can see you got some boxes here. Has anyone had any interest at all? And they're like, no. This is what I'm running into with hydraulic cylinders. It's just like, nope, we're not doing that. Anyway, I thought you'd get a kick out of that. If you back away from it, you can see I'm just using very close camera angles. I haven't put it in a YouTube yet, but I think it's, why not have some fun? What the heck? Anyway, that's for later. And enjoy, and I will keep you informed.